Hi guys, Danny, Xdrift Industries. Today we're going to have a look at our Mustang project. We have spent the last few weeks, we've made a spindle, we've got the frame position bent up, the upper part of the frame that actually bolts into the chassis. We've got our crush tubes done, and now we sort of get to the tricky part where we're going to set our ride height and work through a couple of challenges like the spring mounts and the upper control arm. So let's have a look. We've chosen the 8.8 2018 model independent rear diff for this project, mainly because the vehicle's still in production. We love our M86, but hopefully we can make this an export product. And what we need to do is make sure that the hardware that goes along with the kit is readily available. And it's for that reason that we've used the Mustang bearing on our fabricated upright. So that gives us the larger diameter drive shafts, and they will be custom linked. We'll get them from the drive shaft shop. We will see what Australian companies may be interested in helping us develop some axles so we can have a range of axles at a range of widths. The front of the frame, it bolts in through the chassis, as you can see. This particular variant, there wasn't a crush tube in the chassis. Now I'm not sure if that is a Dynacorn derivative or whether it's possibly something that we'll need to account for. Either way, the plate that you see up against the chassis there has a 1/2 inch inside diameter tube that's welded to it, and then it pushes firmly up against the inside of the rail. So when that bolt's tightened, it's not just flexing in the side, it's actually well supported and it'll hold everything together. Similar down the back, we have another plate with a 1/2 inch ID tube welded to it. So basically, the idea would be when you get the kit, you put your front bolts in first, leave them a little bit loose, and then you push the back of the frame up until it touches the chassis rail. And what we'll do is we'll supply a little jig that you drop in the tube, and then you run a 1/2 inch hole right through the chassis, and that will then need to be made larger on this side for the crush tube, and you simply bolt it up and your structure's then in place. So let's have a better look at the spindle. Again, like all our frames, we're basing it on the AU architecture. When we change distances from that, we try and keep them scaled. So this one's going to be a particular challenge because we will be running a relatively shorter lower arm with a similar length upper arm. Here's our spindle when it's removed from the hub. Okay, so this is how we arrived at the basic size pickup points. So we've used the AU spindle. So we're replicating the AA arm system with the control arm. Now one of the key points we wanted to address was we wanted to upgrade the wheel bearing. The wheel bearing on the AU, we haven't experienced any direct failures. We had to make sure we put locking nuts on the axles. They did try and back off, but since we put the locking nuts on, it has been fine. However, we've identified that is a weakness, and as you can see, the AU spindle is integral for the bearing carrier itself, whereas the Mustang one is a bolt on. And you can see how that is running a much beefier bearing, which is ideal for what we want to do. So it's all together. What you can see is the upper pickup is much lower on our own spindle. We've moved that centre point down 50 millimetres to give us a little bit more chassis clearance for the upper arm. The less of a bend in that upper arm, the stronger it is, and obviously strength on that part, it takes a lot of the torsional load. You don't want that bending. A bend there will cause a big change in toe and alignment, so the stronger we can make the upper arm, the better it's going to be. Now, as you can see, we're going to have to remove these bump stop mounts, but not necessarily the coilover will have the bump stop internal there, so that's how we control the maximum travel. Like whenever you're drilling a hole, always helps if you centre pop it just starts a hole off where you want it. I've centre popped these ones too. It's going to be a little bit tricky to get down to that bottom one. We may have to use a long series drill, but we're going to do our best to get this off without doing too much damage to the chassis. You can see where it's just dropping through the top plate, so we'll leave that one there. You can see when they made this floor pan, they've also put a little bit of weld around the outside of it. They go on this side of the car, there's a little bit more excited, more weld on. That's easy enough, we just need to get a cutting blade on the angle grinder and we'll just carefully trim that away. Once you centre pop it, you find it centres very quickly. Again, you can just feel it coming through, but it makes very simple and clean work of removing that spot weld. Now we're ready to get our grinder, cut those top welds free, and we're going to very small chisel and very gently try and pry this bracket off. To finish it off, just a little bit of an edge primer so I don't lose that lovely unrusted steel underneath. So the Mustang subframe follows a similar path as what the version 1 and version 2 subframes do. What we're looking at here is what we're going to weld in to be the bottom of our subframe. This will tie the back together, and it also provides the mounting points for the lower control arms. Now we're sort of getting a little bit smarter as we go, so If you have a look at the version 1 subframe, it's a very organically shaped thing. We've tried to mimic the AU frame, and as a result, we built another one. We want to simplify the angles, and then we come back to this one, and to make it easy to draw, easy to bend, easy to notch, most of our bends in the subframe itself are going to be 90 degrees, much like when we have a look at the way this pipe comes down. It's a pure 90 degree bend. That makes it a lot simpler when it comes to notching, and getting a good fit is really important before we try and weld it up. The better the fit, the better the weld, the stronger the weld is. So what we'll do is we'll grab what we've got for a left hand. So our plan is to tie this one in like that, just in where my hand goes. Between my hand and the diff is where we're going to make an allowance to have an exhaust. And then we've worked out the bend radius, which is approximately 180 millimeters. We've just marked this end of the tube that it's going to be set in the bender, so that part of pipe will be 45 degrees down. And then here is our line, or where the radius will start, or the start point for the bend, and we're going to pull that around 90 degrees. Then once we have the two bends in place, that's when we'll work out the length of it overall, and we'll notch the end so it will drop straight down on that pipe and over here as well. Starting to feel like we're getting somewhere now. We've got the lower subframe bars bent and notched. We've used a very handy angle finder app just on our iPhone, so we're working with a tolerance of roughly ½ degree. Again, making the primary bends at 90 degrees. It's just made it a lot simpler to get the notching done, so we're pretty happy with our fit and finish. So what we're going to do now is we're going to tack it up into position. Then we're going to grab the trusty old standard AU arms, and we're going to calculate their average length. So between the two inner pickups, we're going to add them together, divide them by 2, and that's going to give us, we'll derive a ratio between the upper and lower control arms. So to keep everything moving where we need to, we'll base the length of the upper arms inside that ratio there, and then we'll be able to move these lower bars. We won't set them until we derive the ratio of the arms. We'll also go back to our original measurements from the AU subframe, and again a very similar thing there. We're going to work out the relationship between the upper and lower and break that down into a ratio so we can replicate the way Ford had that AU wheel move in the very beginning. pretty happy overall here. We worked out the ratio is going to be about 1.5 to 1, so the bottom arm will be 1.5 times longer than the top arm. That way we can retain the AU geometry, if you like. We can scale it to suit this application. So the next thing is, need to make up the hub for the left hand side of the car. Once we do that, we'll set that set the right height, and we'll be able to then lock that hub into position relative to the frame here, and then for the first arms we will create them from where they need to be on the subframe. Once we work that out, then we'll jig them up, and that'll be a good way of working out, making sure that they're exactly the same left and right. Pretty excited. Any feedback as far as what you guys want in regards to track width and also ride height? Now's the time to let us know what's ideal. We've got an idea where it needs to be, but the feedback is what ultimately we need to know, so when people buy our kit, it ticks all the boxes. Thanks for watching.